to the Big Data Debrief. It's a recurring show where we interview movers and shakers in the big data world. Today's guest is Zhamak Dehghani, the CEO and founder of Nextdata and the original creator of the data mesh concept. Zhamak, welcome to the show.
Thanks, Alex. Great to be here.
All right, I'm glad. I'm glad that you agreed to this interview. Yeah, we've been talking several times over the years, and we also named you a person to watch for Datanomic back a few years ago. So you have definitely been very influential in creating some of these ideas and these concepts, especially around data mesh, which you popularized with your 2019 report, "How to Move Beyond a Monolithic Data Lake to a Distributed Data Mesh." That was a big report. It's been cited all over the place. But I mean, 6 years has gone by since you first published that report. Um, eh, how has the data mesh concept changed since 2019, or maybe it hasn't? Maybe it's the same.
Yeah, you're right. The concept was first introduced as the next evolution of data management in a more decentralized fashion, as opposed to technology enforcing centralization. I think the concept itself really was composed of articulation of the pain points around scaling data management as organizational scale, and be able to kind of speed up data to value with trust embedded, right? So this was a really the pain point was around scaling data management in line with the organizational complexity and growth, not so much with the volume of data growing or the speed of data accelerating. So it was really an organizational problem. And I think that problem remains to be the problem statement that we're still grappling with. In terms of the concept, the concept introduced a set of promises that we can, with a set of first principles, that the only way we can really scale out kind of data management in a way that many different parties could be involved in the soup to nuts of data value from creation to discovery, we have to give the ownership and that responsibility back to a larger number of people in organizations, and we have to align that with the ownership of data management with the business, because that, or business units, because that's how organizations grow, right? And the moment you have a centralized bottleneck like centralized IT, we know that that is a friction point. So scale with the promise of domain ownership, and speed with the promise of this kind of self-serve platform that hides a lot of data complexity, with trust built in to data as a product being produced and shared through federated and computational governance. So I think what has remained from that is still this promise that people are looking for, right? There are hundreds of companies that I have either worked with or talked with over this, like 6-7 years since the inception of data mesh, and still today, that is the nirvana. That is, people can kind of squint their eyes and see, yeah, that alignment of business domain and data management can be the only way out of this problem that we have with the speed and scale and trust. But I think what hasn't really happened is the technology that really makes this possible. I've seen a ton of investments and a lot of kind of projects and programs and transformation programs, that some are still running, some failed, that tried to bring that to life. But I think all of them were done in a vacuum of reimagining what does data management experience should look like. We're still using the same technologies. We're kind of wiring them maybe slightly differently together. And I think that hasn't materialized. So long way of answering your question to say, I think the promise still is relevant.
Mhm.
The kind of target state remains the same as a set of first principles, but the path to get there is evolving and will continue to evolve. And I was very, very intentional when I created the concept of data mesh to really introduce it as a set of first principle and avoid putting any technology in, because whatever technology if I had included any solution in that, it would have been irrelevant very, very, very quickly.
Right. Exactly. It's obviously there's no silver bullet to solving some of these data management challenges. It's interesting that you mentioned that you came up with the idea, and it wasn't a response to the growth of the volume of the data or anything like that. So what? And people have been struggling with data management, challenges, ever since the first data warehouse was created. Gosh, I don't know, 30, 40 years ago. So what
Yeah.
was it in 2019 that gave you that, aha moment to this is the path that we should follow?
Yeah, I think it was, a lot of moons aligned for that to kind of resurface as like as a potential path forward. And one of those was that I was engaged back then. I was working with ThoughtWorks. I was engaged with a lot of data projects, and I think it was a moment in time where people have got over the bump of, yeah, we can have our data on cloud. So the data on cloud was well accepted, many data cloud migrations in progress, so many done already.
Mhm.
And now what, right? So now we've done that, we're still not seeing value. So I was working with a lot of technologically fairly advanced companies here in the Bay Area, West Coast of US, that had done a ton of investments. They had hired the best data scientists you could find, and those people weren't really delivering business impact at
Mhm.
the end of the day. So the data to value where was still a very localized, experimental, or really localized set of efforts, a set of projects. So I think that, and the combination of kind of looking back at history of computing and seeing where did we see this problem before and how did we solve it, and what are the ingredient of those solutions that we can bring to data world. That was, for me, that was the aha moment. And because I naively came a little bit left field, I didn't come from the traditional BI and warehouse, so I had this maybe a first timer kind of perspective, or a new perspective to come from outside. And with the support of a lot of people that have been working in the data space, we kind of that idea came to exist. But I think it was just a moment in time where all the tools we thought we needed, were available to us. The cloud, data stacks, all of the big vendors were fairly established, but the results weren't still universally accessible or noticeable, measurable in large organizations. And it always came down to the bottleneck of people and the bottleneck of organization, less of the bottleneck of the technology, although technology was influencing and reinforcing that the way it was designed. It was designed for centralized use.
Right. Right. So you mentioned that the growth of the cloud was one of the factors here. If companies put all of their data, or they build a data warehouse in the cloud, doesn't that make an argument for centralizing your data? Yeah, I mean, isn't
Yeah,
isn't that the centralized data repo? I mean, it's where's your data? It's in the cloud.
yeah, fair question. I think there is two. You're right that when we think about this combinatorial kind of problem of data management, one aspect which is a source of a lot of these tensions, is where your data is, or how your data is being used, and the use case and the format of data and all of those. And if we try to put all our eggs in one basket, we're back into this perpetual cycle of getting the data into the basket so we can use it. And until it's in the basket, we can't use it. And when it's in the basket, it's already stale, right? So I think that's a great argument to say that's not necessarily the solution, I guess. And I think I do agree that, if that's your, I don't know if that's your point of view, but I do agree that the next generation of technologies need to embrace this diversity across many different dimensions of um, kind of dimensions of diversity of data management. And one of those dimensions are the clouds. uh, I think we have to accept that as the laws of physics of this universe of data management, that the data won't be in one cloud. I think my point was mainly around the fact that people had moved their data to cloud. People had got over this problem that they thought, well, the problem is put my data in cloud and I get results. They had done that and the result wasn't there. So that couldn't have been the main issue, right? So that was okay. So then what next? But I do agree with you that, multi-cloud, multi-location, it's just the reality of how data will get connected and we get use out of it. So whatever solution we have has to have that as a, first class assumption.
Yeah. I think you're right. I mean, the cloud is really nothing else but just somebody else's server at the end of the day, right? Whether the data is there or in your own data center. It's never going to all be centralized. It seems to me that we're at another inflection point in big data tech these days. It wasn't that long ago, back in the Hadoop days, we were told you had to bring the compute to the data, right? Because the data was so big and immovable. But it seems like maybe it's the compute now that's too big and immovable, especially with GPUs. And data silos just seem to be growing everywhere. So, it, you know, I think maybe the polls have flipped. I'm also recalling something that David Flynn, the CEO of Hammerspace, said recently. When he was on a call with Altimeter Capital. They just raised $100 million, and he says that the conventional wisdom of move your compute to the data doesn't hold anymore, right? And I mean that's the
Mhm.
reason the capital invested a lot of money in his file system. So is that have the polls flipped at this point? Have we just officially given up on data centralization and we're going whole hog for data decentralization at this point?
Yeah, I think that's another factor to consider. That one is, bringing the compute kind of where the data is and the data gravity, but also universal compute. That every kind of data processing will have the same form of compute. I think um, both of those dimensions of factors will require a more decentralized approach, as in use the right compute where it's relevant and where it's appropriate for processing the data. So I do agree, and I don't think it's the pole of now we trickle the data into the compute, and we weren't doing that, or trickle the compute to the data. I think um, at least from my perspective, when data becomes like what we call data, uh, is actually stopping us to reimagining solutions in a very, very different way. I think one of the mental blocks that I hope to change, and we call this, once upon a time I called it this concept of data product, and that got abused and misused. So now I'm calling it autonomous data product to reclaim what it was. So I think the data really it's data and compute together. That
Hmm.
is the unit of sharing, processing, monitoring, governing, and what that compute that lives with the data, or data that lives with the compute, whichever direction, but it's the logical encapsulation of those two together, makes it possible to do many interesting things, including kind of embedding the compute related to governance with the data, embedding the compute related to verification of the data with the data. So, and it is a more of a logical construct than a physical construct. So I think we will forever probably bounce back and forth between these poles, and we have to, in my mind, reimagine what data is as something else that is not just bits and bytes. That's then somebody else processes.
Okay. Yeah, I think we probably are destined to kind of bounce back and forth between the data centralization and decentralization. I mean, for some types of workloads, you absolutely need to have the data local, right? I mean, particularly for like training an AI model. So I mean,
Yeah.
in some cases, you have to put up with the pain of trying to centralize it in order to accomplish your task,
Yeah, can
right?
I make a distinction though, Alex? I think we are sometimes lock ourselves or our solutions to what the physical layer needs to be. So there is and physical and logical is always relative, right? From the point of view of the observer, whether something is physical might be actually logical to some other observer, depending on where you are on the stack. But I think if we did separate, and we've done that a few times with data virtualizations, and maybe there's another round of that to be done, is that the the actual physical storage of where data lives and the actual physical location of where the data processing jobs are running, that can be independent of this kind of logical layer where we are managing what is shareable, what is accessible, what is maintainable, manageable, entities that I call in the language of data, I guess data mesh, data products. So I think if we allowed ourselves to kind of separate those two while allowing these aggregations of data compute around, for example, business domains or whatever access around which we want to aggregate, those become first class, still physical entities, as in they have their own compute, they have their own footprint on infrastructure. They're not just some logs in some catalog tool. Then we can have our cake and eat it too, which is put the data and its underlying compute in whatever permutation of locality and where location you want, but from the perception of the people that try to find it or use it or even create it, it's the same management experience. So when I talk about decentralization, it should allow any permutation of that physical layer all in one basket or all in different clouds, and that is an orthogonal decision based on the criteria that you're describing in terms of the type of compute and the volume of data or security, the compliance, all those factors. You can make that decision orthogonally. Than how does the data management experience look like?
Okay.
So I
I
just
think
want
that
to put
makes a
that
lot of sense.
differentiation out there.
Yeah, that makes a lot of sense. So, how you're accessing the data and what compute you want to bring to it, what jobs you want to accomplish, that's completely separate from the management and the governance of the data.
Yeah, yeah, I know. And then from that perspective, I think the governance and the management needs to become more decentralized
Hmm.
and at the same time standardized. Because if it's decentralized and it's standardized, then it can cater for kind of this problem of complexity, like inherent complexity of all these permutations, that data could be on any of these clouds, or it can be stored in any of these formats, or it can be accessed in many different ways because agents and humans like to see their data very, very differently, right? So you can have all those permutations, but yet have a kind of a standardized way of even articulating what is a shareable data is, or how these data products getting managed or orchestrated or produced or connected with each other. There's a set of capabilities that fit into that management layer, um, that can be standardized in a more decentralized way, as in you don't need a centralized point of control or catalog or whatever we want to call them today, uh, but is a standardized to allow us to cater for diversity. And I think that's, again, when I look back to history of our industry, moments in time where where we see those kind of Cambrian explosions of so many different technologies. That's when internet happened. You have so many devices and routers and computers and IoT and big servers, and we yet are capable of connecting all these pieces together and having meaningful applications and diverse applications on top. And the reason for that is because we had the tech stack with a narrow waist. We had a tech stack with a set of decentralized, standards, TCP, IP, and so on, that
Hmm.
allowed that diversity and permutations underneath, diversity of experience on top, without locking everyone into a single experience, a single bottlenecked, server. But yet we had some decentralized concepts that we brought to life. In this case, was internet protocols, and I think we need the same thing for the data stack.
Yeah, I would agree. That's a great way to put it. But the challenge, of course, is once you put your foot down and say we need this protocol for this type of data and this data format, then of course there's going to be 20 other ones that you're going to have to support. And, it's
know. I'm curious, Alex. Like you've been looking at the industry for so long. So if I could ask you, what does it take? Like in the data space, I think it feels like the adoption always wins. So if you have something out there, it's not like designed by consensus. There's no never consensus. It looks like people create these technologies and become a de facto standard in a way through mass adoption, and that's the only way it gets some sort of an agreement as what it could be. But that's always temporary because something else comes after. But I'm curious, what
Yeah,
do you think it would take?
I mean, it's tough. I think data management is always going to be hard, just because the types of data keeps changing, the data formats themselves keep changing, right? The use cases keep changing. So it's probably just as diverse as the human experience, really. I mean, data is just what we write down. I think it's always going to be hard. I mean, in a way, it's like trying to grasp water, right? As soon as you think you have it, it just slips out of your hand. So it's a little bit ephemeral in that way. But then there's successes like in the data lakehouse, which is uh, a form of centralized data management. Something like Apache Iceberg has come along, and it's really standardized things and allowed people to get more benefit out of a centralized data store. So I think it probably just takes time to figure out, what are the standards and protocols that we want to have. And it
Mm.
sounds like, for a data mesh, the idea of a data product is really the foundation that you want to build on.
Yeah, absolutely. I think the iceberg is a great example. I think if it maybe need to be kind of in an emergent way as opposed to TCP/IP, that was maybe a group of people that designed what it was and it didn't like kind of emerge organically. But I think in the case of data stack, maybe it's more of a organic emergence of layer of standards. And when we talk about iceberg or table formats that allow us to do some sort of a transactional processing on top of non-transactional kind of storage, to me it feels like thank God we finally agreed on what Ethernet packet formats needed to be on the wire. Like it's a still fairly low level, very key and very important layer of that data stack, but it is at a still a file. We're talking about file formats, right? So or table format, sorry. So necessary but not enough. And uh, I hope that at least, I mean, that's the position we've taken, is that there are other layers in this stack that the concepts need to be kind of codified, and then a bunch of people have a go at it to build their versions of it, and hopefully someone will have a version that is better or stickier, easier to use, and gets widely adopted, right? So for the way I see that narrow waist is that you've got the kind of more standardizations around compute, hopefully more standardizations around security. Unlike web, that very quickly we realize that we have to have form of authentication and authorization that is the standard, so that we can connect all these services together without having logins and passwords for every single service. Data stack needs to kind of get there as well, so there will be layer for security, I hope, like authorization, authentication, and access control, and so on. We're not having an attempt to kind of create that layer. I hope somebody else does. The layer that we think is missing is this encapsulation of the kind of the soup to nuts of data management, so that when somebody is trying to generate data as a valuable product or discover it or govern it, what is that simple, really simple experience that they can declare their data product as, and they can discover, and they can get access, and then get access to the underlying storage, right, and then use it with the underlying compute, whatever their compute is. So that data product, simplification of a data product as a composition of a set of affordances or set of capabilities into a simple experience, which then applications and users and humans and agents and so on
Mhm.
can work with. I think that is a layer that I'm convinced that is missing, and it's a layer that at least the industry has had a very kind of positive response to it in terms of wanting data product to be the notion of synonymous with data now. So I think that that is another missing layer, but it's not the only one.
Okay, and so let's talk a little bit about your startup, Nextdata, and the product that you launched. I think earlier this month, earlier in April, Nextdata OS. So this is your product for addressing some of those challenges that you just talked about, right? How does Nextdata OS do that?
Sure. Yeah. So we kind of codified this concept of autonomous data products. So we looked at kind of all the friction points in the data management layer and considered all of the diversities that sits beneath the data management, mainly compute, storage, maybe the way we manage quality and we secure data. And then we've created this concept of self-governing, self-managing, self-orchestrating, like a small, really product, piece of software that then different teams can build or share as their data products. And these kind of self-managing autonomous data products can connect with each other, share access to data with each other, and they can connect with each other semantically as well. So first and foremost, we had to think about, again, Nextdata is at the service of decentralization of data management ownership. So that's a fundamental problem we're trying to solve. And we believe that's the really only way we can get scale of innovation with data and speed of innovation with data, because we've got to remove the human bottleneck out of the way and the management bottleneck out of the way. So these self-managing kind of autonomous data products then allow any team be able to define them, run them, they generate their own data, they provide access to their own data, they orchestrate the compute that generates the data, they're self-governing, they're imposing contracts and data in and data out, and they're providing discoverability to others, and all of their capabilities are accessible through a unique API anywhere in the world, right? They're not tied to kind of any centralized platform. So we build it, even our platform is fairly decentralized. So every data product has its own kernel that's running. So once you have that, then the OS itself provides a set of capabilities to people that needs to build them.
Right.
So we augment the existing kind of workflows that either data scientists have or data analysts have to generate data products. We provide capabilities to people that want to discover them and get access to them. So we provide discovery and access experience. We do not serve the data. We delegate that to the underlying storage. We do not kind of run the compute ourselves. We delegate that and we drive that through a driver technology to the underlying compute. So you can have this, multimodal data, um, multi-compute data, and we just manage that. So we provide capabilities for access. We provide capabilities for governing it in a more federated and computational way. So you can, internally within the data product as a developer, define what controls you want to have on it and what expectations you have from the upstream data, what promises you're making semantically, or kind of using kind of processing the data according to a set of rules or a set of code computationally. So we enforce that, and then we provide an experience for managers to be able to see the insights from a mesh of connected data products. What is the consumption of the data? What is the cost of running the data? Which of your data products are most used? And so on and so on. And we built this platform and that kernel and the data product, autonomous data product, with two big kind of constraints in mind or requirements in mind. One was that data product need to be universally usable regardless of the use case. As in, if they are agents that want to access, let's say you're providing, I don't know, sales predictions for the next 3 months through a particular data product, that semantic of sales predictions need to be available through the same data product for an agent as vector data and as to an analyst as a set of relational tables, and maybe to traditional ML as set of unstructured or semi-structured files. But the management and creation of those modes of data is all encapsulated by the same data product. So that multimodality for AI or ML analytics is built in. That was one of the requirements that we had. And then the other kind of requirement was that we want this data product to have this adaptable architecture, that it always provides a unified set of capabilities without on top of diverse set of data stacks. So you might have a permutation of data stack with, I don't know, Snowflake, for example, and collaborating tools. Um, it looks the same as if as another data product that is running on Databricks, that they can connect with each other. And that's easier for us to do because we don't try to solve the actual data flow problem. We delegate that, of course, underneath. So as long as data can flow within those two systems, we
Mhm.
provide kind of the management side of it. So diversity, multi-stack, and then this multimodality were two of these permutations of, complexity that over time organizations have to deal with. I've got, five different data stacks, and I've got so many different use cases, and I have a hairball of, data pipelines for each of those, and another, kind of piped to and wired together set of technologies. How do I get out of this mess? So we had to take that complexity on and say we have to hide that complexity.
Wow. Okay. You're doing quite a bit. Are you integrating with other tools to do that, or are you taking all of this upon yourself with like a data catalog, data security,
Yeah.
access control, etc.?
Yeah, so we don't we delegate, we drive. We have this concept of like drivers, just like an operating system that you can, run applications, and you kind of what OS does is abstracts the concept of application or process, let's say unique process, but that process through drivers can, run on different CPUs, different hardware, can access files on different disks. So we have a similar kind of architecture, that we have a driver architecture that manages. You see, our job again is not read or write or, provision access. Our job is managing that underneath and delegating and drive different technologies in a similar way so they can do their job without exposing the complexity to the user. So we have drivers for storage, and we have quite a few of those storage drivers already out of the box provided. We have drivers for compute. So if the different type of processing, SQL processing versus streaming processing versus batch, all different kind of processing on different stacks, security and quality. Even the data quality itself, like we have this concept of, I guess there are now known data contracts, but we call them like kind of promises and expectations. But those promises and expectations to, let's say, we want to make a data product, want to make a promise that, I don't know, it's like, let's say, cancer research for a certain population of the patients, and validating that only that population is part of this cancer research data product. It's like women of 50 years old and plus, and validating there are no men or children in that population. We delegate that to the underlying data quality tools that do that job really well. So
Okay.
we'd have a driver for quality. But we make that like super, super simple for people to bring all these concepts together, the compute, the logic they're writing, the semantic model they're defining, and the quality rules that they're building with a simple experience. And then underneath, we are managing the complexity of delegating to different technologies. So we don't have to solve all of that, but we do solve some of it. Um,
In terms of integrating with other vendors, say if they're using DBT for transformations, or like Atlan for a data catalog, are you able to work? Are your customers able to continue to use those tools and bring Nextdata OS in as well?
Some yes, and some would be transitional. I think it would be a funny overlap between us. So a lot of these tools, for example, DBT Core for sure. So DBT Core as we consider it like a transformation kind of engine, right? For us is a compute that we can delegate to. And that itself delegates to actually Snowflake underneath. So for some technologies, is more straightforward because they fall into that four category of compute quality, storage. I forgot the fourth one. Oh, security. For catalogs, we are still figuring that out, frankly, because catalogs, they're a completely inverted model of what we have built. Catalogs right now, their job is catalog the stuff you have on disk, right? So they kind of crawl and they look inside, and then once they do that, they give humans ability to kind of add more, or the machine's ability to add more metadata to it. We are the inverse of that, that every data product out of the box provides real-time information that is accurate and up to date and always in sync about what's this data, what it is semantic, like all of that rich metadata is coming from living, breathing data products that then you can surface through, tools like catalogs. So because of that backward way, that like these are two different models, we get to kind of figure out what that meaningful integration is. We do have some examples of kind of experimentation, kind of way of doing, to say, the catalog is, can support metadata for maybe data products that are not live or smart, or whatever, like the existing data. They're not really data products, right? And then surfaced, through our app. But we need to figure that out, because it's a very two different models of thinking about what constitutes data product and whose responsibility is to provide that data.
Yeah, and a lot of the data catalog vendors have gone into governance as well, or some of them came from governance and then went into data catalogs like Calibra, right? So,
Yeah.
so who are the intended users of Nextdata OS, and how are they actually interacting with your product, and what are they doing?
Sure, yeah. So most of our customers already made the jump to this like data product or data mesh oriented way of working. So they have people that are responsible for building and managing data products. In many cases, those users as the developers. So this is a multi-sided platform. So you have developers building data products, and those could be, your existing data platform team or data team, or in many cases, these are data people within the business units themselves, but they're still, fairly familiar with data and data workflows. They could be any spectrum: data analyst, data engineer, data scientist, because we are not dictating them how they should write their logic, right? We package their logic as a product, but we're not dictating how they write the logic. Hence, there's a wider spectrum of, from data analyst to say data scientist to data engineer. We haven't really built a layer on the production side, although we have some examples. We showed in our demo where kind of Gen AI looks at your existing code and creates data products for you out of the box, but it still requires someone that understands data modeling and a little bit more data savvy than, maybe a business person that is just putting spreadsheets together. So that's kind of where we are on the data product developer side. On the consumer side, again, it could be business, it could be, the consumption experience is very fluid and very intuitive, intended for business users or data scientists, data analysts, anyone, but definitely business users can use it, get access and use the data, get to know the data, get to trust the data. That's a much wider spectrum of users that can come and use the discovery experience. And then people that are kind of managing the platform, usually there is like a platform owner, which wear two hats. Usually they wear a bit of a business facing hat, which is, what is our answering questions such as what is the ROI on data? And today they can't really answer that question because their data and data processing is across 5 or 6 different platforms and they don't have visibility. So it's the kind of, we call them platform owners, but their job is either business facing, answering, what is the return that they're getting from investments on data, or their business is more technology facing, making sure the health and availability and resilience of these data products. So we have a surface area for them as well. platform owners. So it's a kind of a multi-sided platform, the OS itself.
So what are they actually doing? They're building data products, data product containers out of their existing data, which is, I guess, uh, database files, files and file systems, et cetera. Is that what they're doing?
So it's either a greenfield or a brownfield. So if it's a case of a brownfield, there is a productization or containerization effort that will happen, and we've done that with many of our customers, and that's where we utilize Gen AI to accelerate it. Of the stuff you have, and the stuff you have is not just files. The stuff you have also includes the ETLs and scripts and whatever code lying around that generates that data. That together around a particular domain, we allow and we have technology to kind of accelerate packaging that as a data product. So that's more of a brownfield. I've got stuff in
Hmm.
on disk in databases and scripts lying around, and I've got all these like hairy pipeline of ETLs. Can you create bootstrap a mesh of data products V1 so that from then on we can kind of maintain it? That's more of a brownfield, which is a lot of kind of projects start that way. And in many cases, these are brownfield data products being built downstream from the data that has already been accumulated and exists somewhere. And these are new processes, new analysis, new predictions. The new machine learning models that need to generate data, and they then create this anything greenfield will be delivered as data products as opposed to yet another pipeline, yet another script, yet another set of files lying around somewhere.
And then the idea is once you've created that containerized data product, that data product container, then from that point forward, your tool, Nextdata OS, is going to help them manage that and govern that, going forward in
Yeah,
a good
yeah,
manner. Okay.
absolutely. And our platform provides a guided experience to build them because as part of building them, you're adding things that traditionally you haven't been really thinking about. You are defining the semantic model, you're defining the kind of semantic rules or semantic the code that governs that semantic. So there's a bunch of things that the platform as part of building guides the developer to do without really getting in their way of how they write their analysis or how they write their code. So our platform provides that experience, and you're right that once then they've created the data products, then the platform gives them visibility and to find those and access those and manage those. And again, we build the platform, Alex, with the intention of it to be ultimately initially an open platform to extend and integrate, and hopefully one day even open to kind of update and change. And by that we mean that we build all of the surface of the platform, surface of the container autonomous data products themselves. They're all API driven. So you can integrate with any of those endpoints, like our insights are just data products that you can use to generate whatever dashboard that you want and not use our dashboard, right? So I think that's like a future step in terms of maturity of adoption of the platform to integrate it more into your unique experiences.
Okay. And so the idea is this is going to be open source. I mean, you mentioned it was open. Is this something that is going to be contributed to one of the foundations, or maybe get some more traction first?
Yeah, we definitely have plans in terms of opening the APIs and integration points first, as opposed to opening the core. That's a lot of work, frankly, that we would need some more resources to do that. But our intention is to initially open the container spec, open the container runtime APIs, open the driver kind of development tooling so that new driver to be can be implemented. So that's definitely an intention because we want it to be, as I said, like an open for integration and open for extension. So opening to building new drivers that um, new compute, new storage. We don't want to be on a, on a, we don't, our roadmap, our product roadmap, I don't want it to be a blocker for people to adopt this to weird and wonderful places where data lives, right? So it's to our actually advantage to open that layer up. So that's an intention.
and potentially to allow other data management tool vendors to integrate into Nextdata OS as well.
Yeah, 100%. Absolutely. Both from the kind of the two, again, every surface of the product can be open for integration. You have the surface of the kind of the foundational technology, such as the compute and storage through the drivers. And then you have the surface of management of the data products, managing their life cycle, getting their insights, the real-time insights that they're providing and events. Yeah, so that could be either other vendors, or it could be, frankly, what organizations may build for themselves, right? The experience, I think it's such a, it is not a commodity. Experience should be tailor built to what is relevant to the context of that organization and the people that they have. So that experience layer maybe even be built by the people. We put a lot of effort in it, and I think our product is beautiful and intuitive, and I love that experience. But we're also open to other people to reimagine it for their own organization.
Okay, great. And so what's next for Next Data? What data innovation, what new features are can we expect to see next?
Sure. Yeah, there is there is a lot of work to be done. I think we, as I mentioned, well, some of the next steps are including how we can open up for the specifications and APIs and integration points. The most importantly, we want to really meet people or developers where they are. So kind of the developer experience has always been don't get in the way, meet people where they are, and then augment their experience. A very, very poor analogy would be like, kind of a experience of Docker, where people were writing applications with a programming language of choice and so on. But when it was time to package that application as a manageable, unit, then they packaged it as a container. So it's a terrible analogy. It's not exactly the same, but it's the closest that I can find. But be able to kind of be closer to where the developers are and where the experience is, and integrating to their IDEs and integrating to their flows. That would be another area that I would invite the audience to actually work with us. We really want to make that super, super, super simple, and the kind of this growth on different areas for extension. Again, the different type of data stacks, different permutations to support those as well.
Okay, great. And of course, people can reach out to you at nextdata.com is your website. Um,
Yeah,
well,
absolutely.
yeah. Well, I want to thank you for joining us today, Zhamak. It's been great to have you on the show, and I enjoyed our conversation, and I hope that our audience did too. Thank you very much again.
Thank you, Alex. I appreciate it. It's just so wonderful to come back. And one day I was recognized as a person of the year. I didn't even know what that really meant, to watch or person to watch, whatever it was. And then now we are here, and there is something more than a person to watch. There's actual product that hopefully is useful to people to watch. So
Yeah,
it's a delight to be here.
yeah. We're definitely gonna watch what you're doing at Next Data.
Thank you.
All right. Thanks, Zhamak.
Thank you so much, Alex.